Well, hello, good morning or good afternoon or good evening, wherever you are, depending on your side of the world. I am so thrilled that even though this is supposed to be a European time zone conference, strictly speaking, given the current state of the world, people from different parts of the world, or so I'd like to believe, are able to be here with us today. Yes, I'm Veronica Lopez. I am a software engineer currently working at DigitalOcean, the cloud company, and I am also part of the Kubernetes project release team. We don't call it the core team in general because we're a lot of people, but we're part of the core team, um, where I have been contributing for over a year in different roles. Nowadays, I'm a release manager associate, but I have been involved in many different parts of the release team, mostly as a volunteer, but it's almost like a full-time job, and it's very exciting. For the past few years, I have been focusing most of my work around distributed systems. That is my favorite area of computing, mostly with Go and some Elixir. And Elixir is, to be honest, my favorite programming language in the world, although for different circumstances, I haven't been able to really use it in my day-to-day day jobs. But I am always trying to use it on my side projects or being in contact with the community and stuff like that. So working for a cloud company and contributing to one of the most popular cloud native projects nowadays have helped me calibrate my perspective on the evergreen importance of choosing the right tool for the job, but highlighting it even more when we're building stuff that impacts thousands or even millions of users sometimes, which usually has an important impact on computer and economic resources for the people building this type of systems. You want to optimize your resources because not only resources are infinite or finite, but money is too. So your scaling strategy or your failure strategy cannot be just like, oh yeah, let's just scale and grow infinitely to support all the users that we need to support, because that wouldn't be sustainable. So most of my work has been around that area, and so that is why today I'm here to present you. This title is very general: Kubernetes and the Beam. I don't know if any of you have ever attended any of my presentations around the same topic, but I promise that this is a little bit different. Well, very different, but obviously I'm along the same lines. And I don't know if any of you attended the past virtual conference where Francesco and I gave the keynote together. And even though that had a completely different approach, I'm going to reuse some ideas, but only to provide a little bit of context where it will be necessary. But this is a totally new talk. Okay, so the structure of the talk will be very, very simple, like a slide introduction, whether Kubernetes or the Beam, then the current status of the tooling, the versions of the things of said tooling, and basically the state of the world. Then I'm going to present the use cases that I decided that they will be three: the deployment, testing, and fault tolerance. And that would be like the main part of the talk. And finally, a conclusion. And don't forget to, if you have any questions, you can make them in the Huba app. And well, if time allows, I will answer them here or there. So let's begin. So introduction: Kubernetes or a Beam language. So just for the sake of simplicity, I'm gonna use the terms Kubernetes and Beam or Elixir interchangeably. Like Kubernetes can be anything in this context, in the context of this talk, almost any modern tool of what we know now as the cloud native ecosystem. And Beam language, I will use it interchangeably with Elixir, because for the purpose of this talk, both of those terms will be interchangeable. So do not get confused if at some point I use one or the other. So yeah, should we use Kubernetes or a Beam language? It's a tough call. They're so different. So this is a reference to the movie The Devil Wears Prada, where the characters are presented with two fashion items that look exactly the same. But since they're fashion experts, they get super offended and they say like, no, they are not the same. They're so different. So basically, I'm here. The purpose of this talk is to tell you how they are different. Because people usually ask me these questions, like when they know what I do and that my work basically converges in both sides. People like to ask me this. And to be honest, at some point, I even asked myself the same questions. So the first of them would be, does it make sense to use both? They seem to overlap a lot. The second one would be, why would you use Elixir if we already have agnostic tools like Kubernetes that let me use basically any language that I want? And the third one would be, why would I want to use Kubernetes? Aren't people reinventing the wheel with tools like that? If these solutions were proposed over 15 years ago, like in distributed systems papers, academic papers, and stuff like that. Yeah, as I said, all of these questions are super valid, because even myself working already, doing the work that I'm already doing, until very recently, I clearly understood the difference of the layers where it would be relevant to use each of these tools. So yeah, really quick, the answer for the first one is, does it make sense to use both? Yes, of course it can. Like, not always, of course. But the fact that we think that they seem to overlap a lot is mostly on a philosophical point of view. And don't worry, I will explain this a little bit throughout the talk. But yeah, the spoiler alert is that the concepts seem to overlap, but you'll see that on the practical level, they really do not. And the second one, the answer for the second one is, why would you use Elixir if we already have agnostic tools like Kubernetes? Well, yes and no. And part of the answer is the same answer as the first, that, well, it like the things do not overlap, the features do not overlap necessarily. And second of all, even though Kubernetes and all these tools were or are designed to work on a theoretical level agnostically, the reality is very different. We still get to have a lot of vendor lock-in. And to be fair, this is not even like on purpose. This is not like a bad intention from most of the vendors to lock you in. But the thing is, like, the ecosystem is still so complex that many times when you're using a managed Kubernetes or managed cloud native services, it is very complicated to just migrate everything, because there are a lot of specific tools that are very attached to a vendor. Although, again, I want to be very clear that I'm not saying that they do that on purpose. It's just like what it is in the current state of the world. So yeah. And then for the third one, so why would I want to use Kubernetes? Aren't people reinventing the wheel? Well, yes, but one of the things that I like about Kubernetes the most is that, from my point of view, it is the democratization of distributed systems. Whereas before, some years ago, before all of this popularization of these tools began to happen, distributed systems was an area that used to be like for very expert people, or like people who had been working on that for a very long time, or perhaps academics and stuff like that. Nowadays, almost anyone can be a distributed systems engineer, and I know that that is a blessing and a curse, but well, it is what it is. And well, but in general, the truth is that if we used every tool for the purpose it was created for to begin with, all these questions would be irrelevant. So, but no, just kidding. Uh, or at least partially, but because like today, I am here as an insider of both tools and both projects to help you understand the difference between the layers and responsibilities of this tool, as I have already mentioned. Okay, so what is the current status, the current state of the world? How does the cloud native ecosystem looks like nowadays? And I am very happy that someone, don't worry if you really do not see the granularity of this diagram. It is sort of on purpose. You can go to the source that I linked here. And this is basically all of the current tools that that exist nowadays in the cloud native space. It's a bit overwhelming, and of course you don't have to use all of that. And if you see like in the second layer where it says scheduling and orchestration, that is where Kubernetes lives. Like imagine all of the rest of the tools are like Kubernetes is just a little part of it, although very, very powerful and very important. So yeah, I am very, very happy that someone decided to use this image to sort of make fun of the current state of the world and the cloud native ecosystem, so that I could put it here because it was very relevant for this talk. And yeah, there are many points of view. One of them is obviously like, who needs all these tools, you know, like when we already have very powerful things like the beam. But on the other hand, and other perspectives are like, well, all of these tools really are democratizing many concepts that were not accessible for a lot of people in the past, also making them easier not only to understand but to implement, even for experts, like people that were already distributed systems experts. Just the implementation, well, it's very different. Obviously, as I said, you don't have to use all of these things, but another aspect is that, well, all of this tooling and their interactions have created many jobs over the past few years. So, well, of course, there are many pros and cons, and it is not my place to judge, at least during this talk. But yeah, so what it is a fact that is too much tooling, actually. Even if Kubernetes is now much friendlier to use and install than a few years ago, despite being a very popular open source project, said friendliness at this point still relies heavily on all of these additional tools. So we can easily end up with a very bloated ecosystem, which demands operators. And in the cloud native ecosystem, we call the people who manage these tools operators. So which demands operators to become Kubernetes experts in order to deploy an app that they probably took less time building than building the Kubernetes pipeline itself or getting used to the Kubernetes pipeline itself. So actually part of my talk with Francesco was about this, like and how hard it is nowadays for developers that maybe just wanted to explore some alternative deployment options. And now almost every developer, every application developer also has to become an infrastructure engineer, at least for some time, at least temporarily, because yeah, mastering these tools is not evident right now. However, many might think that this happens for technical reasons or the lack of thereof, that maybe people involved building these tools are not probably capable enough. I'm not saying that. I'm just saying that it could be like a very popular assumption, or like that people on one side definitely do not communicate with people on the other side, or that they are not aware of each other, stuff like that. very relevant to distributed systems theory. But I mean, the truth is always in between, right? But in my experience and in my opinion, I don't think that the main reason for this to happen are purely technical reasons. I think that given the popularity of the projects, many companies have created entire business models or even entire companies themselves around Kubernetes tooling. So it shouldn't come as a surprise that there's a constant race among them to launch newer and more impressive tools every day. Like myself included, I used to work in the past at a company that at some point its only business model was an installer for Kubernetes, because this was a few years ago. So at the beginning of Kubernetes, when it started being open to the public, it was so hard to install manually that actually people paid actual money to real experts to just go and install it for you. No, like not even manage your installation or anything like that, like only the installation. So there were some companies like CoreOS, where I used to work, that at the very beginning, their only business model was to create an installer for it. And after some years, the business model evolved, of course, but just imagine that. And this was not even, I'm not talking like 20 years ago or 10 years ago, it was very recently. So yeah. And the truth is that with all the competition, all the explosion of this tooling and their interactions, there, as in everything in software engineering and computer science, some things may or not be necessary or even useful, but I mean, that's okay, that's natural. That doesn't come like from a place of judgment. I think that's normal. And rather than investing time in improving the native user experience, like the core, like many developers, rather than contributing to the core or the open source upstream project itself, well, they decide to build all this external tooling, which obviously makes sense, because that's what pays. That's what pays the bills. Like not every developer is fortunate enough to be paid to just contribute to upstream projects all the time, right? So basically everyone wants a chunk of the cake, and who can blame them, or who can blame us? Even though I do not get paid for it, but you know what I mean. So yeah, going a little bit back to this diagram, let's say. We can find everything from databases, messaging, service meshes, app definition resources, image building resources, scheduling and orchestration, so much more. And someone even made this meme. I think they did an amazing job, because yeah, that is basically our jobs when you work in a company that relies heavily on cloud native tools. So for a little bit of context of, well, for those of you that are not very familiar, or that are in this talk to understand a little bit more, even though this is not the core of the talk, just for a little bit of context, I created this diagram based on other talks. For you to understand a little bit where the main difference lies between the Kubernetes usage and the Beam usage, and why it really does make sense to use them together when it makes sense, if that makes sense. I know it will. It will. It was just a joke. So in this little diagram, I compared three main concepts that people that I've met and throughout all of these years find either interesting or overlapping, or they want to find a tool that solves these three different problems for them. And in my opinion and in my experience, these three items are the ones that cause the most resistance or the most confusion. So the first one would be the fault tolerance. So Kubernetes does it at a cluster level, whereas the Beam does it at an application or language level. So In the case of Kubernetes, it automatically restarts containers that fail, like entirely, like it basically saves the world. Whereas the Beam restarts parts of the application. And how the way they would supplement each other if we were to use both of them is that if we had a failure on the application level that makes it or parts of it unresponsive to health checks, which is how Kubernetes works, like constantly assessing the state of the world and comparing it to the desired state that you previously stated or wanted. Well, as I said, it will save the whole thing. On the other hand, having control of fault tolerance from a language level, and therefore from an application or systems level, makes it easier to make more granular decisions to define a failure policy, right? So in this case, we have both benefits. And the second item or second problem to solve is like service discovery. So on the Kubernetes side, we have that this comes built in, this comes out of the box. And one example is like the service meshes, but there are many other mechanisms like etcd that allow this service discovery. And the way it does it is by automatically listing and managing the connections of the existing nodes. And for those of you who are not familiar with this vocabulary, don't worry about nodes. Just think of this as an instance, a Kubernetes instance. So it automatically lists and manages the connections of the existing instances, Kubernetes instances, out of the box. Additionally, cloud-native tools like service meshes, such as Istio and etcd itself, have like dedicated infrastructure layer built right into the app. There are already some tools for the Beam languages, like libcluster, for example, which provides a mechanism for automatically forming clusters of Erlang nodes. It provides a publish and subscribe mechanism for cluster events so that you can easily be notified when cluster members join or leave, which is basically how Kubernetes acts. And projects such as Partisan already take advantage of this. But I mean, someone had to build this externally. And that is if you use distributed Erlang or distributed Elixir, but it still has to be configured manually. And on the third node, we have the live code changes. That is also like a very hot, no pun intended, a very hot request, and many distributed systems and concurrent systems nowadays. And the way Kubernetes does it is by rolling updates, which means that the updates happen like in small subsets or in small batches, not at the same time, so that in case the update of a certain subset fails, the rest of the subsets or the rest of the application and the setup is saved, and then it rolls back to the previous healthy state, right? And in case everything goes well, it is only considered successful once every subset is already updated. And well, if you're familiar with the Beam and Erlang, for example, and the live code changes work via hot swap, which talking to different developers nowadays for modern applications, modern simple applications, quote unquote, they are like, but I don't need a hot swap. But like, let's remember that, well, the Beam and Erlang had a different type of origin compared to what Kubernetes is today, right? So, well, what we're trying to say with this is that there's this popular phrase that says, every tool's a hammer if you want it to be, which means that any tool can become whatever you want. But in this case, we can use that creativity somewhere else, because we definitely have the tools to be able to build very robust systems at different parts of the layers. Think of the OSI model for distributed computing, for example. And you will find the right layer the right problem and the right solution on the right layer. So yeah, so this now allows me to jump into the main section of this talk, that is the use cases. So we have the deployment and orchestration, which you will see that, in my opinion, it can be a hybrid strategy between Kubernetes and the Beam. Then we have the testing that what I will present here is more based on the containers approach, therefore on Kubernetes. And the third one, fault tolerance or reliability strategy, depending on the layer. And well, in this little diagram, it is like a visual representation of literally how they overlap, like not completely, but like some things here and there. Okay, so we go to the first one, that is deployment and orchestration. This is the part where we describe the application's lifecycle in Kubernetes and in the cloud native tools, such as which Docker images to use for the app, the number of pods there should be either available or the minimum required. Many policies, the bare minimum of how your system should look like to operate, both based on Kubernetes restrictions, but also on your own needs, and the way they should be updated, with these rolling updates, like you can define your policies. So that is very top level. if you're not familiar with this, this is just very top level. And if you're very familiar with this, I think you can understand why I make this shortcuts for the sake of simplicity and time, right? Here also is where we define through an object, a Kubernetes object, how we want our Kubernetes clusters workloads to look. After an object has been created, the cluster works to ensure that the object actually exists. What I was saying about like this health checks, whether it is alive or it is even available, stuff like that. And maintaining the desired state of your Kubernetes cluster. Obviously, this can be done manually in general, but the fact that it can be done manually doesn't mean that we should do it manually. Not only because it's very tiring and frustrating, but because we can make a lot of mistakes. So it is not recommended. And if you're using any CI/CD system, well, this step is a must. Like containerize your stuff, and then ideally orchestrated through Kubernetes or a similar orchestrator. And strictly speaking, nowadays in many teams, the people responsible for this area are the release engineers, if there are any in an organization. And I know that they do not exist, or this figure doesn't necessarily exist in every team, and I am not saying that they should, but I just wanted to point this out in case it helps you see the picture clearer. And yeah, so this doesn't have anything to do with Elixir or the Beam itself on a language level. So this means that this is a use case where you could have already defined everything and take advantage of all the Elixir or the Beam's capabilities on one hand. And this use case for everything that I have already described relies entirely on Kubernetes. So this is a use case where using both of these tools completely makes sense without overlapping. In other words, even if our Elixir app code was perfect, it doesn't define the infrastructure policy of what I just described, right? So that would be a very nice use case. There's just a special case that I have found, an edge case, let's say, that is not an exception, it's an enhancement. So I was talking to a friend recently that they are actually using this strategy, but also for auto-scaling, not only for the deployment, but for the auto-scaling, because they're using a very specific setup where they are actually storing the behavior of the Elixir app in containers, not only like the entire environment to be able to deploy it into their CI/CD, no, but also like they're storing some parameters of their setup that is very specific. I think it's a software or a library that takes care of video streaming, I don't know, encodings and stuff like that. So in order to, autoscaling is very, very expensive in those use cases. So they will use this container approach for autoscaling, but not in using their specific setup. But as I said, it's not even an exception. It's just an enhancement of the same use case. The second use case is testing. This might sound super simple, and it really is, but like working in this space recently, well, for the past few years, I don't know if any of you are familiar with the container-based testing approach, where it is just as it sounds. It's as silly as it sounds, where recurrent scripts and tests that can be packaged in containers are packaged like that and run as part of the build pipeline. So let's say this is also like a hybrid strategy because on one hand, because once you are done testing your native behavior, for example, I can think of using Proper for property-based testing that has become very popular in Elixir systems recently. Of course, that lies entirely on the language level. That has nothing to do with Kubernetes or cloud native. But then once you're done with that, maybe you need like some extra tests that run on that do not run locally, that run on your CI/CD pipeline or anywhere in between. So if there are things that you will usually run and run and run time and time and again, a very modern quote unquote method that I have seen a lot for productivity purposes is that you literally contain all of those tests into a container and ideally into put them in an orchestrator, and there you go, there you have it. And then again is another use case where the properties of both ecosystems enhance each other without stepping on each other's feet. Sorry. And well, the third one and last one is the fault tolerance and reliability strategy. Unfortunately, I have seen, and I am sure that you have seen this too, that one of the most popular use cases of Kubernetes out there nowadays, and probably why this is the main reason why people are so confused of like whether it is useful or not to use both of the tooling or the two ecosystems, is because a lot of people use Kubernetes as their only remediation for reliability or fault tolerance strategy. You know, like they put everything, all the responsibility into Kubernetes, which is obviously like if you're a Beam programmer, that will give you a heart attack because you cannot, it is not a good idea to do that, right? Like ideally you would take care of that many steps before. Now, I'm not saying that using Kubernetes as a reliability tool is bad. Like, of course, go for it, because like that is actually one of the etcd, like one of the main Kubernetes components mission, like to provide the reliability and Kubernetes itself. But we have to understand that there are two different layers. Like, for example, if we were to use Elixir and Kubernetes and for the same project, then you don't have to choose where to use the fault tolerance. We can use both, actually, like the meme of the girl that is like, why not both? Well, this is literally a use case for that, because you take care of the fault tolerance that is built into the Beam languages, well, into the Beam, and you can also take care of the reliability and the fault tolerance strategy on an infrastructure level. So then you have both of them. And as I had described, like in the very beginning, at the Kubernetes level, it will fix everything, like the whole installation, whereas at the language level, it will solve the part of the application that is unresponsive. So you have, in this case, even though you would, strictly speaking, have like overlapping strategies, I think it is not bad. It is not bad to have both of them. And I think that this wouldn't be considered as like a bloated system, because you would be taking advantage of the two built-in features of both ecosystems. You wouldn't have to use additional tooling. And just as in the same in the same way that I pointed out in the first use case, that just to provide a clearer picture how the deployment and orchestration in modern companies nowadays would be the responsibility of a release engineer. This fault tolerance or reliability strategy is usually the responsibility of the figure of an SRE or a DevOps or even a sysadmin nowadays. Then again, I am not saying that only those roles are able to deal with this. It's just for the sake of simplicity and clarity. And well, the conclusion for this is that since most of the modern container technologies like Docker and CoreOS, for example, there are many others, were built following the popular Linux, Bash, and Go combo, a lot of people have preferred to stick with those for day-to-day expansion and development. And since these tools do not have built-in fault tolerance capabilities, for example, Go doesn't have that, it is a rumor that for Go 2.0, 2.0, this will be included. We don't know yet. But the state of the language nowadays is that you have to provide those mechanisms, like as a developer yourself, manually almost, or at least with third-party tools. It is normal that since most of the Kubernetes community decided to stick with the Go programming language, for example, that they would think that it is a really good idea to use Kubernetes as their sole strategy for fault tolerance remediation and reliability and all of those things. So I am usually very cynical about these comparisons and even a little bit negative. If you've seen any of my talks around this topic, sometimes I tend to make this like very confrontational comparisons. But since I have seen that these questions are very popular over and over again, I really wanted to shed some light into like the reasons why this happens and how it really makes sense to use both ecosystems. And well, without any judgment, but being very aware of what is available for us, and so that we can design better strategies for failure instead of just avoiding them or putting everything into Kubernetes or any other tool for that matter. So yeah, that is it. Thank you very much for your time, and let me know if you have any questions.
Thank you, Veronica. This is awesome, and I really like your pragmatism here on the right tool for the job, which is always a good thing. So great talk. Let's see if we have some questions. I'm going to check out the Hoover app. What are your thoughts on the new buzzword, serverless or function as a service?
Well, I think that if it works for people, that is great. But I think that I would also take the same approach that I just mentioned, like be aware of what serverless can offer and match it with, like, first make a list of the issues that your system or app has and see if they can be solved strictly with the language level or at an infrastructure level, and if serverless is the right tool to solve the infrastructure level things. But yeah, I mean, I have never used it, and I don't see myself using it in the near future, but I think that if it works for people, they should go for it, but always being very mindful. Yeah, no questions. Just
Oh, it
great.
was crystal clear. No, but coming back to this with serverless, I think that the concept itself, or the name of the concept, is very strange. But I can see that startups, if they want to get quickly to market, that to have various functions available to them, and they can get their business logic, they can focus on that, and then all the hosting and all the scaling and whatnot sort of can be handled in such an environment. And maybe they don't need to go into all the details because they don't need to. They want to focus on as a startup, you want to get your first customers and those things, rather than thinking about scaling and all the things that we love in the Beam community, and that Kubernetes and other tools are really helpful with. So it's like a different problem to solve, sort of.
Right. Yeah, exactly. As I said, I have never used it, but I do know that that ecosystem has, or sub ecosystem has improved a lot in the recent years. So probably if you had asked me like 2 or 3 years ago, I would have told you like that it wasn't worth it, because what I knew back then is that at the end of the day, since those tools weren't mature enough, at least the people that I met that were using them ended up fixing them manually
Hmm.
because they had a lot of flaws still. So it was like almost twice the work, because they were relying on those type of tools, and in the end they would also have to tweak them manually, and in order to tweak them manually they would have to get familiar with
Wow.
the underlying technologies.
Yeah.
So it was a little bit worthless.
Uh,
um, but nowadays I have heard amazing things about it. It's just that I haven't had any opportunity to use it. But I am sure that with time it will just get better and better.
oh no, it seems we have a question here. Let's see, it's from Sabah. Does the Elixir nodes in your cluster communicate with each other? Do they use Erlang distribution?
I think I cannot see the question, so can you repeat it?
Yeah, sure. So it's from Sabah. Do the Elixir nodes in your cluster communicate with each other? Do they use Erlang distribution?
Yeah, like it. I don't know if the question is like when you're already working with Kubernetes, but well, yeah. What I'm trying to say is like if you're using distributed Erlang or distributed Elixir out of the box, this is not supported, and that's why tools like the one that Partisan uses exist for that a main reason. I mean, you can also do it manually, but you have to explicitly mention it. Whereas with Kubernetes, this is out of the box. This comes out of the box, and like all of your nodes or elements, let's call it them for the without loss of generality, um, they interact. They are discovered, like what you call service discovery in distributed systems. That comes out of the box. So that is pretty cool, actually. So that is that's why it is a very cool use case. Like even if your application is written completely in Erlang or Elixir, and you don't want to mess with any other manual configurations, and you are still going to use containers for other purposes, just for deployment purposes, well, you might as well use Kubernetes for service discovery capabilities and all that. And that way you don't have to use additional tooling.